Good morning, children. Now, continuation of chemical bond. So, we have seen that the valence electrons are the one which decide like whether an element or an atom takes part in any chemical reaction. And as well as we have seen what Lewis and Causel has proposed for formation of the bonds. Now the next part is types of bonds under that ionic bond. We are going to now look at ionic bond. Ionic bond is also called, from its name itself it is very much clear. Ionic means you are going to have ions, positive and negative ions. And you know how the positive and negative ions are formed. In the previous class we have already discussed, like when a neutral atom gives out an electron, it becomes a positive ion, and when a neutral atom gains an additional electron, it becomes a negative ion. We have seen that. Now the bonds formed between those ions are called ionic bond. From name it is very much clear, right? So this is also known as electrostatic bond. Why is this called as an electrostatic bond? Because the force of attraction which is between these two ions is the electrostatic force between two opposite charges, one being positive and the other being negative. And this is also called as an electrovalent bond. So the three names are ionic bond, electrostatic bond and electrovalent bond. So now according to Causel, how an ionic bond is formed, so what are the factors which will decide the formation of ionic bond, that we are going to see now. Okay, so ionic bond is formed between two dissimilar elements. That's the first proposal, the first statement from the Causel's theory of formation of ionic bond. So ionic bond is formed between two dissimilar elements, two different kinds of elements. It's not something like a bond formed between hydrogen and hydrogen. It's not a bond formed between nitrogen and nitrogen. It's not a bond formed between oxygen and oxygen. It is something like this is formed between two dissimilar elements. Okay, so now let us see a particular example how this is formed. Now let us take Na, that is sodium, which is an element from alkali metal, right, whose electronic configuration is 1s2, 2s2, 2p6, 3s1. That is first shell 2, second shell 8 and third shell 1, where valence electron 1 is the valence electron in the third shell. And now this Na, by giving out an electron will become an Na plus electron is emitted or electron is given out. So this already we have seen how we will get a positive sign here, like by already they have 11 protons, and neutral atom there should also be 11 electrons, but one electron is given out here, so only 10 electrons are here. 11 protons and 10 electrons, that means one proton, that means one positive charge is extra, hence it will become a positively charged ion. We call it to be ion, and the name given is cation, and the positive ions are called cations. This is how a cation is formed. That means from a neutral atom, when an electron is given out, a cation is formed. What is a cation? That is a positive ion. Right, now let us see like how an anion is formed. Okay, so let us take the chlorine, which is from halogen group, right? So chlorine, its atomic number is 17. It has 17 protons and 17 electrons in its neutral state. Now one more electron it is taking. Now we are adding it to chlorine, the neutral atom of chlorine. To it we are adding an electron. So thus what happens here? 18 electrons and 17 protons are there. So one electron, one negative charge is high, extra. So therefore it will form a negative ion, and these are called anions. Right? These are called anions. So positive ions are called cations. Negative ions are called anions. Now if we see the electronic configuration here, it is 17 means 1s2, 2s2, 2p6, second shell complete. Third shell 7 are there, 7 electrons. Now by adding an electron, now the anion configuration is 288. So that means one more electron is added into the third shell, and thus it has obtained an octet. That means the outermost orbit is having 8 electrons, therefore it will become very stable. So what is that now? Here you have a positive charge Na plus and a negative charge Cl minus, right, with equal magnitude. Signs may be different, but magnitude is same. That is, here the charge is going to be 1.6 into 10 power minus 19 coulombs. Here also 1.6 into 10 power minus 19 coulombs. But here this is of positive charge and this is of negative charge. Both charges when brought near to each other, right? So that is Na plus Cl. That means whenever sodium and chlorine has to are brought sufficiently closer, then they will form as Na plus by the sodium giving out an electron to chlorine. An electron is given to the chlorine and it is sharing, it is giving out, it is contributing an electron to it, it is giving out an electron to it. So this will become Na plus, and now as it is taking an electron, it will become Cl minus. So, and now these are two ions, so they together combine to form NaCl, which is a neutral compound, So what is the general formula? A cation plus an anion gives rise to a neutral compound. This is how an ionic bond will be formed. This is how an ionic compound is formed. So what is happening before the formation of the compound? The elements are becoming ions. After they are becoming ions, that is a cation and an anion. So when they are brought sufficiently closer, they will split into cation and anion, and thus they will form finally a neutral compound. Okay, so now the second statement what he gives is, first statement is it is formed between two dissimilar elements. Second one is usually this comes out from highly reactive metals and highly reactive non-metals. So both the elements should be highly reactive. They must be ready to react. So one should be ready to give out electron, the other should be ready to take the electron. Maybe 1 electron, 2 electrons or 3 electrons or whatever it is. So one element should be ready to contribute electrons, the other must be ready to receive electrons. So one should be a donor and the other should be an acceptor. Here Na is a donor and Cl is a acceptor. So sodium is donating. These are the alkali metals. Here in this particular example, these are alkali metals, and chlorine is from halogens. So second point is the ionic bond is formed between highly reactive metals and highly reactive non-metals, where metals are ready to give out electrons and non-metals are ready to receive electrons. So that means one should be a donor and the other should be an acceptor. And the third one, what he says, causal, he says that noble gases are chemically inactive, so we are not at all bothered about whether an ionic bond is formed or not with this what we call the last group, what we call as inert gases. And the last one is valence electrons. That means whether it is 1, 2 or 3. So they tend to lose. Those which are ready to lose electrons will become cations, and those who are ready to accept will become anions. These are the 4 points that you are supposed to write. What, according to causal, the ionic bond is formed. How an ionic bond is formed and what are the characteristics. That means what are the things which let the ionic bond form. Okay, so pause the video for a moment. Take the screenshot. Please prepare your own notes. This is very, very important. And now the second part. Now let us see the formation of, so we have already seen in the example itself formation of sodium chloride. We have seen the example formation of sodium chloride already. So that is usually chlorine. So it exists in the form of Cl2. Therefore here we are taking as half Cl2 Thus, so from here one electron and is given out, and here this is shared, and NaCl is formed. And the cation formation, sodium, it gives out an electron and forms Na plus ion. Cation, so here this is a cation, and now the anion formation, that is a chlorine. It takes electron and then it will become an anion, that is Cl minus ion, and thus when both of they are combined, then NaCl is formed. Now let us see the magnesium chloride. Valency of magnesium is 2. Right? Chlorine usually we take as Cl2. That means each chlorine atom is ready to take 1 electron. Here 2 chlorine atoms are there. So it takes 2 electrons. Mg valency is 2. You can see here. Electronic configuration of magnesium is 282. That means 1s2. Here 2s2, 2p6. Second shell is totally complete. Third shell 3s2. So what are the valence electrons of magnesium? 2. So it is now ready to contribute 2 electrons. So it is giving out 2 electrons and is becoming 2 plus. So this is the cation. Now the next one is anion. Here chlorine. How many chlorines you are taking? 2 chlorines. So therefore here each chlorine is ready to take 1 electron in order to get an octet. So here 2 chlorines need 2 electrons. So therefore 2 electrons are added to 2 chlorine, and therefore it becomes 2Cl minus. This is the anion formation. So please, this is very, very important. It can be asked under 2 mark question, or also with 2 or 3 examples can be asked as 4 mark question. Okay, so thus the cation is formed, that is the magnesium 2 plus is the cation, 2Cl minus is the anion. On combination you will be getting magnesium chloride. Now next one is for formation of disodium monoxide. So disodium, di in the sense 2. You are taking 2 sodiums combined with oxygen. Why? Because oxygen has an electronic configuration. It is like something, it has a vacancy of 2 electrons. Thus it gives out 2 electrons. Each sodium atom gives 1 electron. So 2 sodiums will contribute 2 electrons and oxygen takes 2 electrons, and thus you will have disodium monoxide. So therefore now how is the cation formed? We are taking 2 sodiums. Each sodium give out 1 electron. Thus 2 electrons are given out. Right? So here this is a cation. 2Na plus is a cation. Now oxygen, which is combined with 2 electrons, it is taking 2 electrons, and see oxygen electronic configuration is 2 6. It needs 2 electrons to complete octet, so hence it is taking 2 electrons here, and then it is the configuration of it. So, and this is how anion is formed. O2 minus is the anion. So now this cation and anion are brought together to form the neutral compound. What is the neutral compound formed? Disodium monoxide. Di means 2 sodiums, mono means 1 oxygen. So disodium monoxide is formed here. Okay. So now formation of aluminum chloride. Here aluminum, here its valency is 3. It is always ready to give 3 electrons. And then now 3 chlorines you are taking here, 3 chlorine atoms. Each chlorine atom will be taking 1 electron. So here cation formation. So aluminum, it is giving out 3 electrons. You can see here, see the electronic configuration. In first shell 2, second shell 8, third shell 3. So either it has to take 5 electron in order to get octet. That means 8 electrons in the outermost. Or it can give these 3 extra electrons out, and thus it can retain with 8 electrons in the second shell. So here aluminum is thus giving out 3 electrons, and then Al3 plus is the cation. Now chlorine, each chlorine takes 1 electron. So 3 chlorines are taking 3 electrons. So 3Cl minus is the anion. So now here the cation and anion are brought together to form aluminum chloride. So thus aluminum chloride is formed like Al3 plus is the cation and 3Cl minus is the anion, and AlCl3, that is aluminum chloride, is formed. Now let us see how the arrangement of ions are there in ionic compounds. So because there are ions, positive and negative ions, now let us see inside a particular, taking an example of a particular ionic compound, and see how these ions are arranged, right? So usually, how, like suppose if you have a positive ion or a negative ion also. If you take a positive ion, that is a positively charged body, right? So it is not necessary that it only ties up with one particular negative charge. There can be a force of attraction in all directions towards a positive charge because of the negative charges. And how many charges will get attracted to this, or how many charges will get bounded to it, usually depends on the size of the ion what you are taking, as well as the charge of the ion. It depends on the charge of the ion and size of the ion. In Na plus Cl, if you take the Na plus Cl ion, because this is only there in your syllabus, already in previous IIT classes you have seen the crystalline structure, how and what, face centered, body centered, right? So such things you have already seen the crystalline structures. Here now we are talking about NaCl only, because this is a board exam syllabus. In this Na plus, each Na plus ion is surrounded by 6 Cl minus ions, and similarly each Cl minus ion is surrounded by 6 Na plus ions. Usually this number, like how many ions are surrounding a particular given ion, is called the coordination number. And what is the coordination number? Thus it is 6. Right? And what is the kind of the structure of NaCl? It is face-centered cubic lattice crystal structure. So what is the structure of NaCl? It is face-centered cubic lattice crystal structure. Okay. So what is the coordination number of NaCl? It is 6. That means each Na plus ion is surrounded by 6 Cl minus ions, and each Cl minus ion is surrounded by 6 Na plus ions. Take the screenshot. See, this is how, like suppose Na plus, the brown, small brown dots are Na plus, because atoms are smaller in size. Alkali metals are smaller in size in the same period. If you go to the right, then the halogens are of larger in size. So Cl is larger in size, Na is in smaller in size. Okay. Now you have taken this. And now, so what it is, Na, these are Na plus ions, right? Now let us take this central ion. Okay, this Na plus is surrounded by 1 and 2 chlorines, 3, 4 chlorines, 5, 6 chlorines. So each Na plus is having 6 neighboring chlorine ions. Similarly, if you take this one, this chlorine here, so 4 are there which are Na plus here. So 2 plus 2, 4. This is 5. And if you would have completed this structure, you would be getting one more like this, Na plus here also. So each chlorine is surrounded by 6 Na plus, and each Na plus is surrounded by 6 chlorine atoms. So please take a screenshot and practice to draw the diagram. Diagram is also important. Now let us see what are the factors affecting formation of cation and anion. Very well, already we discussed this in periodic classification of elements, how the properties will be changing from left to right and from top to bottom. And again we shall recollect, like what is the tendency for a cation to form? It should be ready to give an electron. For anion to form, it should be ready to take an electron, is it not? So therefore, what are the para characteristics? Metallic characteristic or electropositive. So whenever there is more metallic character or more electropositive, then the element has a tendency to become a cation. And non-metallic property, whenever it is of a non-metal and electronegativity is high, then the element will form an anion. So very well, from here we can conclude all metals have a tendency to form cations, all non-metals will have a tendency to form anion. And when you go into the transition metals, usually in between, like whenever you come to the third or fourth or fifth groups, this rule may be changed depending on the other participants. This rule may change depending on the other participants. That is a special case, and of course it is not there in our syllabus. Right now let us confine only to this part. Okay, now all these characteristics are also decided by atomic size. Suppose if the size is very high, means nuclear force of attraction is less on the outermost electron. Hence it is ready to give out electron. When it is ready to give, it becomes cation. When the size is very small, it is ready to accept anion. So now here ionization potential, if it is low, it forms cation. If the ionization potential is high, it forms an anion. Electron affinity, if it is low, it forms a cation. Electron affinity is high, the element will form an anion. So those elements which have high electron affinity will show a tendency to accept an electron. And elements which have low electron affinity will give out an electron. So now electronegativity, which is low, it will become a cation, which is high, it will become an anion. So this is all about ionic bonds. Take a screenshot and try to make your own notes, children. Very important part of the syllabus. So in the next class we shall see covalent bond.